In the first table, I show you the quantity of labor, the average product of labor. If you wanted to get to the total output in agriculture, you multiply the quantity of labor by the average. So one worker would produce 9 units of output, 2 workers 16 units of output, 3 21, 4 workers 24, and 5 workers 25. Analogously, in the manufacturing sector, one worker produces 16 units of output, 2 produce 24 units of output, 3 24, and 4 16. So you see very quickly this function approaches the maximum, and then we have negative marginal returns. So I take the first table and I rearrange it, where in the third and fourth columns I write the quantity of labor from 0 to 4 in a reverse manner to what I had in the first table, and the average product 16, 12, 8, and 4. And I do this so that you can see me sum the quantity of workers to 5 at each stage of the analysis. And in the fifth column, I show you the difference in the average product. So I'm taking 9 minus 4 equals 5, 8 minus 8 equals 0, 7 minus 12 equals minus 5, 6 minus 16 equals minus 10. So this is the difference in the average product. And if I have the difference in the average product being equal to 0, it means that the average product in agriculture is equal to the average product in manufacturing. In other words, if I equate the average product in each industry, so I'm saying each worker is getting paid, or producing and getting paid, the same average, 8 and 8, the difference now is 0, that the total output under those conditions would be 40. Notice that when the average product is equated, or is the same across two sectors, we do not maximize the total output. In fact, you see, when the average product is 7 in agriculture and 12 in manufacturing, the total output is 45. Let's go to the third table here, where I use now, instead of average product, marginal product in agriculture, marginal product in manufacturing. If you want to get back to the total output, we would sum the marginal products. So one worker produces 9, as we said here. We said 2 workers produce 16. So 9 and 7 are 16. 3 workers produce 3 times 7 is 21. So 16 plus 5 is 21. 4 workers produce 24. 21 and 3 are 24. 5 workers produce 25. 24 plus 1 is 25. So when you sum the amount produced by each worker, you get the total. And here, when you multiply the average by the number of workers, you get back to the total. 2 ways to get to that total. We're looking for the smallest difference in the marginal product. In the ideal case, we want the marginal products to be equal, so the difference between the two marginal products is 0. In this particular analysis, because we only had a small number of units to work with, notice that the smallest difference, minus 3, and when the difference is the smallest, in the ideal case when the marginals are the same and the difference is 0, we would maximize total output. This point then helps us to understand that equating marginals is the economist's principle for maximization. Equating averages will not give us that same outcome.